Okay.
Let's continue from where we left off. The whole thing is that what we are trying to do, we are trying to write a program. We are trying to write a program to find out if a number is odd or even. Let's go back to the top. Are you okay? Right. So we don't know what number we are putting in. So we are assuming that the number is n. Okay. All right. So if the number is n, then we want to actually assume that the number can be any number between 0 to infinity. Is that okay? So we don't know what the number is. Now, after obtaining the number, we want to initialize a counter. Are you okay? So that is what I was talking about before the line ended. Okay. So the counter, we start with I equal to 1. Is that okay? And then we want to increase the value of I after we've actually started, the count. Are you with me? All right. So now n will be, let's take a number like 2, then n is n minus 2 minus 2 times 1. What is 2 minus 2 times 1? That is what? 0, isn't it?
Yeah.
So you realize that our r is now equal to 0. Is that okay? So if you put in n equal to 2, all right. If n is equal to 2, so we've been able to determine that r is even, but then we have to write the instruction. But let's assume that the number is very huge, a very large number, like 200. Do you think that this test will pass if I equal to 1? Then 200 minus 2 times 1 is what?
200 minus 2, that's 150 times 1.
198.
198.
198. So we realize that 198 is far away from the test values, and the test values are what? 0 and 1, isn't it? The remainder has to be 0 or 1, right? So 200, then we got a long way to go, but we don't have a problem. Computers can do a repetition. Are you all right? So all we are trying to do now is to keep on increasing the I value, which is already set to 1. And we want to now increase it. Are you okay? If we haven't exhausted, if the difference between this and that is not really very small, are you okay? I don't know if you follow what I'm saying. So if you have a value like 200, for example, then we have to keep on increasing the I until we get 0 or 1. I don't know if you got what I'm saying. Yeah. You have to keep increasing the I so that the I will be going to 2, 3, 4, 5. Are you with me?
Yes.
So for something like 200, what do you think the I will be? The I will get to what value? Then we get a 0 or 1.
N is 200.
No, the N, if the N is 200, what should the I be for us to detect that it's even or odd? I'm talking to the whole class. So Juliet is trying. Please, what about the others? Why are you quiet? If you don't understand it, to tell me. Pilot, are you following it? Ben, are you following it? Amang, are you with me?
Say times 0. I will be 0.
So 200 minus 2 times 0 will give you 200. So R is equal to 200. It's not a good test. Are you okay? So I don't agree with you, Juliet. It's a good try.
You said N N
I said,
is,
what should the value of I be for R to be 0 in the case of n equal to 200? In the case where the value that we are testing for odd or even is 200, what should the value of I be? Are you okay?
yes, yes, yes.
I hope you get what I'm
Okay.
saying.
Yeah, I get to know. So N,
So what would it be? It's very simple. The answer is very simple. It's easy to figure out. What should the value of I be in order to get yes? What should the value of I be in order to get R to be 0? Because the test, remember that we are testing for, let me go back up again. We are testing for R to be 0 or 1. Is that okay?
mm-hmm.
Here. This is the test. And we thought it made sense that every number which is odd is a remainder. If you divide by 2 and you get a remainder, are you okay? Then it means that it's odd, right?
Yeah.
And if you don't get the remainder, which is R equal to 0, then you have even. Is that not the case? All right,
Yeah.
great. So we said in our steps, we said first step, get the number of interest. All right, so that's n. Right, then we said set a counter I, or set a I to be 1, and then put it in here into this machine here. When you put it in there, then when you subtract and you get R to be 0 or 1, and it means that the number is odd or even. But if the number is very large, like what we are seeing up here, then you have an issue, isn't it? You have to
Say,
increase the
but
value.
if N is 200, right?
Yes.
Minus 2 is 198.
No.
198 times.
Okay, hold it. Yeah, let me tell you something. When you have a formula like this, you don't do the subtraction first, you do the multiplication first. That is called
First,
BODMAS. Have
okay.
you heard of
Okay.
BODMAS, right?
Yeah. That's true.
So actually you do the 2 times first, then you do the
Okay.
subtraction first. Are you okay?
Yes.
Okay. So can you give it a go? So first
Yeah,
multiply
I'm
2
trying.
by a certain number. It will give you a certain number, then you subtract it from 200. It should give you 0 or 1. And what is that number?
100.
Yes, it's 100.
100.
It's
Yeah.
100. Okay, it's 100.
Yeah.
So when I is equal to 100, you have 200 minus 2 times 100, which is 200 minus 200. Then you get
0.
0. Are you okay?
Number 0.
Hmm. Okay. So what we are going to do is that we are going to simply increase the value R. We are going to check first if the R value, okay, so we're going to check if R is equal to 0. Are you okay?
Yes.
Or R is equal to 1. Are you with me? If that is the case, then we are done. Are you with me? If not, what do we do? Anybody? Let's check. Hey, what happened here? Very good. So if R is 0 or R equal to 1, we want to go to a certain step, isn't it?
Yeah.
So we go to which step? step C 4. Let's go to step 5.
Yeah,
I know
I'm
step 5. Before you talk, you mute your mic. It's very simple to do that, please. All right. I know Juliet is not happy with what I'm saying, but I'm Makan. All right.
I'm sorry, I forgot.
I know, it's okay. So let's go to step 5. Step 5, we are going to say that if R equal to 0, then display the number is what? The number is even. Is that okay? Is that not the case? Okay, now display number is even can also be another step. So instead of saying display, we can just say go to step 6. Are you okay? All right. So step 6, go to step 6. All right. So step 7 is going to be what? Display number is what? Odd, right? Okay. All right. Now, if R is not equal to 0, in step 3, yeah. In step 3, else, okay. Go to step 4. Okay, we're not going to step 4 yet, but what should we be doing if R is not 0? Let's go to step 4 and do something interesting. Now in step 4, we want to take I and then increase it by 1. So this is how we increase a number. Now you take the number, you add 1 to it, and then give it back to the number. Are you okay? So put this in your mind that in programming algebra, you can always take a variable, okay, add something to it and set it back to itself. This is not possible in the math algebra class. So in the algebra class, you can write something like x equal to x plus 1. This is never done. Mr. Can you never accept this? Are you okay?
Yes.
But then in programming, this is possible. In programming, this is saying that take a variable, add 1 to it, and then set it. So in programming, we actually do what we call the equal sign is more of an assignment operator. And the assignment is from left to right. Are you okay? The assignment is from the left-hand side to the right-hand side. This one I'm teaching you, there's no need to ask a question. This is how it's done. Okay, so this is not accepted. This x equal to x plus 1 is not accepted in maths, but it's accepted in programming. Please, fashion team, put it in your head. Is that okay? Among, you understand that tree? Put it in your head.
No, I don't understand that one.
Okay, you are learning anything. Fashion team, put
Yes,
it in
no
your
problem.
head. Is that okay?
Okay.
All right. So we're going back up here, and now in step 4. Now look at step 4 again. So I equal to I plus 1 means that what was the value of 1? Do you all remember what the value of 1 was? It was 1, isn't it? So because I was 1, now what is the value of I when we go to 4? Step 4. What is the value of I? Is 2. And why? You always try to explain so that we don't ask you again. Why?
Said add 1.
Because 1 plus 1 is 2, and then we give 2 to I, isn't it?
Yes.
So now I becomes 2. Okay, great. Yeah, sometimes explaining certain things certain things are difficult, but that is exactly what we need to do. So when I becomes 2, and remember that we are doing this because the number that we want to determine whether it's odd or even is actually a very large number. So what do? We go back, okay, to which step? Which step do we go back to? Go to step. Which step do we take the new I, which is 2? So we take it to step 2. Are you okay? We take it to
Yeah.
step 2. And then in step 2
Where
now,
R is equal to
exactly. So now step 2 is now beginning to be, there's a repetition happening at step 2.
yeah.
All right. So now if the n is what, 200, now what is the value, the current value? Now that we have increased I by 1, what is the value of R now at step 2? 200 minus 2 times
196.
exactly, which is 196. So we have a long way to go, don't we? We will be going, if we will test for R value for whether it is 0 or 1. We always find that it's not. We will not go to step 5. Are you okay? We rather go to step 4, increase I again. So now you realize that quickly I will now begin to increase from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to what? 100. By the time it reaches 100, the R will now become what? 0. Is that right?
Yes, sir.
And then we would have determined that the number is odd or even. So we realize that this program is done. So how many steps have we used? 1, 2, 3. In fact, we used 8 steps. Are you okay? With some conditions in it. Okay. So beautiful. I know the board is not looking the handwriting is it's not that good, but I think it makes sense. If we go through the steps, it does make sense. Any question on this? So this is a program that determines whether a number is odd or even, and it works perfectly. What do you guys think? Do you understand it? Because I'm going to give you an assignment. Do you understand it?
Yes, sir.
You do understand. Okay, so let's do a flow chart for it. All right, so to do a flow chart, you need to look at the steps. So the first step is what? To get a number n, isn't it? So I think I need to lower up a bit. Okay, so get n. Okay. What's the next step after getting the n? Were you writing it down? We set I equal to 1. Okay. So it's an input. So we are using a rhombus. Set I equal to 1. Okay. Setters and getters. What's the next step? Nobody was writing, isn't it? Very serious class, isn't it? Let's compute R equal to n minus 2 times I. So the computation will use a rectangle and not a rhombus. So compute R equal to n minus 2 star I. Okay, so this is a flow chart. I'm drawing a flow chart for it, and I'm expecting all of you to be able to make a flow chart for, because you are learning at this stage. Now we need a condition. The condition is that is R equal to 0 or R equal to 1. Are you okay? Then we go to step 5. Okay, so we need to put a rhombus here. Big one of that. So it's R equal to 0. I think we need to test for every single, if it's R is 0, we do one thing. If R is, so let's go back and look at it properly. If R is 0, we go to step 5, okay, and then step 6, okay. But here I think it's better if we actually check for the two conditions. If R is 0, we go to this direction, okay. Else we do another condition. If R equal to 1, so here yes, no, are you okay? And then if still we are getting no, then we need to actually go back to step 2 up above. Yes, okay. So here if R is 0, output we use a rhombus display. Number is even, okay, and then here display number is odd, okay. All right, so if still no, if no, R equal to 0, he said no. We checked R equal to 1 as well, no. So we are now having no for this. So in the steps, in the algorithm steps, what did we do if this is not true? Else go to step 4. Step 4, we check, hey, what have I done over here? Okay, step 4, we do the increment I equal to I plus 1, then go to step 2. Okay, so that we want to implement that graphically. So if not, we are going to do certain computation I equal to I plus 1, but I has been set to 1. Remember that, okay. And then from there, where do we go to step 2, isn't it? So we can now okay, let me try and see. I'm struggling with my lighting here, you know. This is actually a proper YouTube video I'm going to be making. So you want to come back up here. From here, I plus 1, and then go back up here. So see the arrows? There are arrows everywhere. I'm not joining just with lines. Okay, great. So this is it, done. But remember that we had to do a lot of brainstorming to understand how to solve the problem. So this is the algorithm on the right hand side. And then down here is the flow chart. Oops. Interesting, eh? Flow charts. Okay. Done. Okay, so at the end of the day, a problem is solved. We can determine if the number is odd or even. Is that okay? All right. Okay, so please, any question, I'm going to ask you to do an algorithm as part of the assignment. Is that okay? But before I do that, let me show you how you do an algorithm in Word, Microsoft Word. So I'm going to show you how you draw that, because I don't expect you to use your hand to draw the flowchart. The algorithm too, you can type it, but you can also handwrite it, but you don't draw the flowchart with your hand like I'm doing right now. Is that okay?
Yes, sir.
So I'm going to show you how you actually do this. Microsoft Word, where are you? Okay, there you are. Exactly. Yeah, so what you do is that you just go to insert, the insert menu, then you go to new canvas, stretch it out, then all the tools are here. So if you want a rhombus, if you're not sure, just go to where are my shapes going? Okay, just pull it down like that. Look for something looking like a rhombus, drag it, pull it there. Okay, you can make it empty and probably change the outline color, make it black. Okay, and you can add some text to it. If we didn't do the start button, but it's okay. You can right click and say add text. And then the first thing was to get in. Okay, so that's how easy it is. And then the next one was to, let's go back to our whiteboard. We get in and then I code, set I code to 1. Okay, so that one also, I think we used a rectangle. We are setting. Are you okay? Right, so you can actually, format painter, click a pixel. All right, so that you don't have to be always setting it to be empty. Add text to it, right click, add text, set icon to 1. Okay, and then you need an arrow, insert. Okay, all right, so we are looking for an arrow. So as you bring the arrow, you see that it turns into this, you get these anchors. Are you okay? You just attach it to it, pull it in such a way that wherever you go, wherever you move the object, it's attached to it. Are you okay? Like this. Okay. See that it's always attached. You can change the color of the line. You can stretch out the canvas. Okay, so that you can make a very nice presentation. If you get to know how to do it, you can do it very fast. Okay. If you want to do a decision, which is not really the next one, the next one is actually an input, compute. Okay, so another text box. So you can just copy also. For example, if you want to copy this, you place your cursor on it, control, drag it. Okay, so we are having another one. Are you okay? Type in the formula. Okay, so let's assume you actually wanted a decision, a symbol for decision, which is a diamond shape. This is it. You just drag it. Okay. Let's see if you can copy format painter. Yes, it works. Insert, shapes, arrow. Get the holder to it. Okay, it's not properly attached. Okay, now it is properly attached. What it means is that anywhere you move the symbol, if you stretch it out, it goes with it. Is that okay? Right click, add text. Then you can write if okay, r equal to 0, and you do the yes thing. Okay, you just click like that. Can press shift to make it horizontal or vertical. Okay, you see that? So that your diagram looks more professional. And you can put a yes there. You say you can put test. You can draw a test. You can draw a test box. You can just do yes. Stretch it out. So this is how you use, mark. So you can decide not to have an outline or two, no outline for the yes, so that the yes should look more like you've written it there, and so on and so forth. So this is how you use Word. Basically, you just connect more boxes, more arrows, more boxes. Then you end up with what we are doing in the Microsoft whiteboard. Okay. So far, very good. So then end up with something like this. But this is nicer. The one we are showing in Word looks more professional. Okay. If it's when I finish with this, you love it more. Okay. Just change the colors around, pull it around, make it nice. Okay. Just don't just do anything basa basa. We are like, you all have to make sure that your work always looks very presentable. Okay. Then when you're done with it, for example, someone could be in charge of this. He does it, he sends it to someone to write this algorithm or maybe the pseudocode. He also write it, take it to someone to actually write the actual code. So in a company where you are producing a program, all this happens as part of the team. They work together as a team, everyone, and then you come out with the final thing. So don't think that, okay, so why are you doing all this? An experienced programmer can write a program without even going through this. But as a beginner, if you don't understand how to do this, you always struggle with your programming. Okay, so guys, this is basically it. Let me see if there's more that I would have talked about. I think the next thing I was going to talk about it's a different topic altogether, but very, very important. We're going to talk about the other paradigms and concepts, which I think we can talk about when we meet again. I think Friday or so. I don't know whether Friday. Information science. We'll check on the WhatsApp. Okay. So this is a different topic altogether, but it's related to programming. The way programming is done today. Okay. We make use of what we call the object-oriented programming. So the concepts, I'm going to be talking about the concepts. I want to introduce it and then we deal with it. But today, the topic, the lecture has been about what? Flowchart and then an algorithm. So you know what an algorithm, you can write, you understand how an algorithm is done and how it should be written. Is okay, and how to translate into a flowchart, or how to translate a flowchart into an algorithm. That's what we have learned today. Is okay. We have done an example using the odd and even number detector. We have created a program like that in this class, and I'm expecting you to do a similar one. So your assignment will be to also write a program. Is that okay? Like do an algorithm and a flowchart to find the maximum number in a set of numbers. Any set of numbers given to you, you should to find the maximum. Okay, so please write it down. Your assignment is to find the maximum of any set of numbers given to you. Okay. Please, I hope you are written. You've written it down. Yeah. determine maximum any set of numbers. Are you okay? In other words, if I give you 2, 3 to 500 and 89, you should be able to tell me the maximum. Same way, if I give you 56 and 70, you should be able to tell me. So remember that this is more algebra than you just writing a story. Are you okay? So you have to assume that the first number, second, subsequent numbers. Are you okay? And you may want to make use of I or J. Are you okay? As a variable, and then set it the first number to be maybe 1, and then you increment it. Are you okay? So the next number will be J plus 1. Are you get what I'm saying? And on and on and on. And then how do you find the maximum of any cell? If you don't understand what maximum is, go and look for it. Is that okay? Class, any question as we are bringing the lecture to a close? Any question? Are you happy with the assignment?
Cybersecurity,
You submit the assignment to me. He said, hello? Hello?
An interesting thing that
Yes.
pops out. Like, are we going to be able to balance these two?
Are you going to be able to balance which what and what?
Two very, very important aspects of the law?
I don't think I'm understanding. Anybody understands what she's saying? Combining two aspects of what and what, I don't understand that. Anybody understand what she's saying? Are we going to be able to combine these two aspects of what? Don't be quiet on me. We don't have time. Please hurry up and let me answer the question. What is she saying? Okay, so please, do you understand the assignment since you are not minding me? So get it done. Is that okay? And submit it to me by email. Okay? Can send it to my WhatsApp. My email, or you can send it through the e-learning platform. So I'll have to set it up there, isn't it? Wow, I think I need to really go there and start setting up questions over there. So I'll set it up over there, then you can supply the answers online. Is that okay? All right. So since you're not minding me, I'll say goodbye and go and get something to eat. All the best. Thank you. Let's meet another time this weekend and then continue from there. Is that okay? All right. Bye-bye. Juliet. Hey, what's me quiet on people, pal?
Yes, sir.
Why have you been quiet on me?
Sir, I'm here.
So you got everything?
Sorry, my network. Yes, please.
So you got everything, eh? Okay.
So no
Yes,
assignment
sir.
today, huh?
You are not talking. The time is up. The Zoom is ending. You are laughing. Think it's funny. I've been asking, ask a question. You have been quiet. Ask the question.